All right, so we were talking about air masses and how they are formed. And so we also discussed a little bit about what happens when they move. And in this case, we want to start talking about some fronts. And this is when those air masses start bumping into one another and creating weather situations that we want to, be aware of for, flying drones. So the one we're looking at right now is an advancing cold front. And that's what happens when a cold air mass advances to a warm air mass. And what happens is warm air gets pushed up the front of the um, cold air mass, and as it rises, obviously, it's taking the humidity in that warm air mass and pushing it up very rapidly. And of course, as it pushes up, it condenses and it starts creating clouds. And in this case, those clouds you see are labeled as CB, which is the METAR coding or the TAF coding for cumulonimbus or cumulus clouds. And when cumulonimbus get pushed up enough, they start towering and pushing upward. It's not always that this happens on the front of a cold front. In fact, here in Florida, we see towering cumulonimbus clouds all the time just because we have that level of heat and the amount of moisture required to create really huge cumulus clouds. Of course, that's where some of the nastiest weather comes from, is in these towering cumulonimbus clouds. But as a cold air mass comes in, you get this warm air pushing up, it condenses, you get precipitation coming down. In fact, some of the world's worst weather can happen on the leading edge of a cold front, as several of these storms may mix together and create what's called a squall line, which is just a cold front moving forward with storms, that have linked up, basically made a chain of storms across a frontal area as that's moving through. You get heavy precipitation. You get turbulence. You're going to have lightning and all kinds of different things that are going to be affecting on the front of a cold air mass in its moving, especially when it's reaching warm air. So a cold front, you have unstable air at the beginning there. It's pushing up and creating clouds. It's creating issues with visibility because you're going to have a lot of precipitation and possibly low clouds. Let's take a look at what that looks like. When you see here, you see a cold front. You can almost see how that warmer air is pushing up over this front. As this thing kind of juts downward, you can see that leading edge of the front. And here's what it looks like when we have a warm front moving forward. A warm front moves completely differently. Warm fronts move at about half the speed of a cold front, and so they gently ride up the back of a cold air mass. As they do that, they get up into the atmosphere, and they act just like you would have on a high pressure day. The clouds that are created are not the cumulonimbus clouds that you normally see on a cold front. They're more of layered clouds, and those are called stratus clouds. And the precipitation that comes from stratus clouds as they move up into the atmosphere is more moderate, light rains and moderate rains. So you get anything from mist to drizzle to maybe a light rain out of this. And this can last for significant period of time. It could even be going on for days. Whereas a cold front comes through very quickly because, as we said, it's moving twice the speed of a warm front. It comes through pretty fast. It's a lot of showery precipitation over a very short period of time. Whereas a warm front is just really kind of moseying along, taking its time, creating these stratus clouds, and just creating very light rains. All right, so on a chart, what do these fronts look like? Well, where you see the red line with the bubbles on top, that is a warm front, and they move counterclockwise around a low pressure zone. Same thing with cold fronts, and you can see a cold front here with the blue line with the sharp jagged points facing in the direction that it's moving, and they also move counterclockwise around a low. When you have your squall lines in front of a cold front, they kind of look like Morse code because there's a dash line with two dot lines and then another dash line with two dot lines. And you'll see this in your book on page 3-6. So chapter 3, page 6, you can find the squall lines. You can also see the troughs, and troughs are basically a line of low pressure, and those are just dashes. And then a ridge is a very jagged line, and those would be drawn on a chart to indicate a line of high pressure. So trough, low pressure, dashes, ridge, high pressure, jagged lines, and squall line front would be your dashes and dots.